Welcome friends to my channel Concepts Coach Electrical, and let's start on another learning journey. This series will be starting on three-phase AC windings, and this is the lecture 1 of this series, and we'll be starting our discussions on lap windings for integral slot electrical machines. So let us start our discussion with a question that what is an integral slot winding? So an integral slot winding is a winding configuration where the slots per pole per phase, or sometimes called the SPP in many textbooks, should be an integer. So if we put it in a mathematical form, so the number of stator slots on the numerator divided by the number of poles and number of phases, this value should be an integer number. So taking an example, let's consider a stator that has 48 slots and our requirement is to wind it for 8 poles. In that case, the slots per pole per phase, this value would be 48 slots divided by the number of poles, that is 8, and divided by the number of phases, that is 3. So over here we are limiting our discussions to 3-phase machines. So that's why number of phases is 3. And the value of the slots per pole per phase comes to 2. So we see that 2 is an integer. This means that every pole that will be created will be using 6 number of slots. That is the slots per pole. Slots per pole is 48 divided by 8, that is 6. So 6 slots will create one pole, and that pole will be contributed by all the 3 phases. So the first 6 slots will create the north pole, then the second 6 slots will create the south pole, and again the third batch of 6 slots will create a north pole, and the fourth batch of 6 slots will create a south pole, and together up to the 8th batch of 6 slots will be having an alternate polarity of north pole, south pole, etc. And this will, as you can see, we have created 8 number of poles that is required for this machine. So out of these 6 slots, 2 slots will be used by each phase to create one pole. That is, the number of slots, the 6 slots package that we are taking for each pole creation, 3 of the phases will contribute to each of these pole creation. So out of those 6 slots, 2 slots will be taken by phase A, 2 will be taken by phase B, and 2 will be taken by phase C. Now moving on to layout discussion of such integral slot windings. We'll start our discussion with a very simple configuration of 12 slot machine, and we'll be winding it for 4 number of poles. So again, by that calculation of slots per pole per phase, this comes to 1. Now over here we'll be introducing a concept of pole phase groups. So pole phase groups is a multiplication of the number of poles multiplied by the number of phases. So in this case we have 4 poles multiplied by 3 phases. So we have 12 pole phase groups. 4 4 pole phase groups will be created by phase A windings, plus another 4 pole phase groups will be created by phase B windings, and again the last 4 pole phase groups will be created by the phase C windings. We have to note over here that for a given number of pole, the total number of the pole phase groups will be same, considering a 3-phase system. So what does that mean is, if I take 8 pole machine, then the number of pole phase groups will be 8 into 3, that is 24. I take a 4 pole machine, it will be 12. I take a 6 pole machine, it will be 6 threes and 18. So this number of pole phase groups remain constant based on the polarity for which we are winding this machine. So this is explained in the last line. We have to note over here that in our case over here we have only one slot that is dedicated for each pole, right? Sorry, for each phase. But if the number of slots can be distributed into multiple number of slots, instead of say one number of slot, I will be distributing my phase A windings in two number of slots, or say three number of slots. In that case the stator slot number may increase, but still the pole phase groups, that number will remain constant. So it is not dependent on the number of slots that you have in the machine. Now let us take another example where we have an increased number of slots, that is 24, a doubled number of slots, but it will still be wound for 4 poles. So in that case we have the slot per pole per phase, that number is 2. But over here the pole phase groups, you can see it is again 4 into 3, that is 12 pole phase groups we have. Over here the thing to note that we discussed, even though the number of slots has doubled from 12 slots to 24 slots, but since the number of poles is the same, so the number of pole phase groups also remains same. So what is the change? Here the change is now each pole phase group will have two coils instead of one earlier. So this is what I was saying. Now that same phase is distributed in two slots. Earlier case, in 12 slot case, each phase coil was, you know, there for one slot only. Here each phase will have two coils, so distributed in two slots. So again the four pole phase groups will be created by phase A, two number of coils. Here you can see there are two consecutive coils in slots like 1 and 2, and again 7 and 8, then 13 14, and then 19 20. Similarly, again four pole phase groups will be created by phase B. Again they will have contributed by two coils, and the third created by phase C, another four number of pole phase groups created by two coils each. Now let us take another example. Another example, we have now doubled the slots as well as doubled the number of poles. So what we have considered is a 48 slot machine, and it would be wound for 8 poles. So here the slot per pole per phase value remains 2, but the pole phase group number, that will now change because the number of poles have changed. So we have 8 poles multiplied by 3 phases, it will be 24 pole phase groups. So 8 pole phase groups will be created by phase A, 8 pole phase groups will be created by phase B, and 8 pole phase groups will be created by phase C. So we have 8 plus 8 plus 8, 24 pole phase groups, which is covering all the slots over here. Now moving on to connections of the concepts that we have learned for 24 slots 4 pole, or 48 slots 8 pole. Those concepts now will be converting it in terms of connections. So we'll take the first example where we had 12 slots, and that was wound for 4 number of poles. In that case, since phase A had 4 of the total pole phase groups, that is we had 12 number of pole phase groups, right? 4 poles into 3 phases, so 12 pole phase groups we had. Out of those 12, 4 was contributed by phase A. So we we call them, the pole phase groups created by phase A, to be ppg1. Why ppg1? Because it is there in the first slot over here, then ppg4, that is in the fourth slot, then ppg7 in the seventh slot, and ppg10 in the 10th slot. So in this way we have given the names for the pole phase groups that are created by phase A. Now these four pole phase groups can be connected with each other in many number of ways. So first possibility is creating one parallel path. So what does one parallel path means? It's a series connection among all the pole phase groups. So over here pictorial we can show that the four pole phase groups, that is ppg1, ppg4, ppg7 and ppg10, all are connected in series with each other. Next comes two parallel path connection. So in that case we have the four pole phase groups that can be connected in one of the forms where ppg1 and ppg4 are connected in series, ppg7 and 10 are connected in series, and in turn these two series connections are connected in parallel among each other. So we have two parallel paths created over here. One parallel path through ppg1 and ppg4, and another parallel path through ppg7 and ppg10. So two parallel paths may also have another configuration where in the top we have the same kind of connection, that is the current goes through ppg1 and ppg4, whereas at the bottom coil we can see we have just interchanged the location of ppg7 and ppg10. So in this way there the connection can be modified, uh, but it will have the same electrical effect or the same flux generation effect in the air gap of the machine. And the third possibility is four number of parallel paths where all the four possible pole phase groups are connected in parallel with each other, thus creating four number of parallel paths for the current flowing through them. And on the similar principle we can create such one parallel path or two parallel path or four parallel path for the other two phases, that is phase B and phase C. But we have to keep in mind that if I am winding phase A for one parallel path, then phase B should also be for one parallel path, phase C should also be for one parallel path. So you cannot mix and match the number of parallel paths among the phases. So if one phase is having two parallel paths, the other two phases should also be wound in similar configuration that is done for phase A. Now looking at the connection of the 48 slots 8 pole machine configuration. Now here phase A had 8 pole phase groups, phase B had 8 pole phase groups, and phase C had 8 pole phase groups. Let us see how they can be connected with each other. The first possibility, that is one parallel path. So here all the parallel or the pole phase groups have been connected in series with each other. All the 8 pole phase groups created by phase A has been connected in series with each other. Possibility 2 is we can make two parallel paths. So two parallel paths, again we have just for the sake of understanding we have taken one possibility where the first four pole phase groups have been connected in series with each other, and the next four pole phase groups have been connected in series with each other, and among these series pole phase groups they are connected in parallel with each other. So four pole phase groups have been taken as a series connection, other four number of pole phase groups another series connection, and you connect them in parallel with each other. And the third possibility is having four parallel path, where again similar to the two parallel path case, here we have taken uh, every two pole phase groups in series, like ppg1 and ppg2 in series, ppg3 and 4 in series, ppg5 and 6 in series, and ppg7 and 8 in series. So we have made four such groups and then connected each of them in parallel with each other, thus creating four number of parallel paths. And the last possibility is the 8 number of parallel paths. So in the 8 number of parallel paths, each of the pole phase groups will be connected with each other in parallel. So here you can see ppg1 to ppg8, each of them are in parallel to each other. And all these possibilities, as in the last case, will be replicated to the other two phases, that is phase B and phase C. Now we again look back at the case of the 12 slots and 4 pole machine, and we target the one parallel path case. So what is the first thing that we do? We do the consecutive, or rather for the phase A, we take the consecutive pole phase group, but they should be of opposite polarity. So one pole phase group, if it is creating a north pole, the next pole phase group should create a south pole, and again uh, the next pole phase group again create the north pole, and the last pole phase group creating the south pole. Then the consecutive pole phase groups must have opposite current direction, just because they are creating, or they should create, opposite polarity with respect to each other. Hence their current direction should also be opposite. Now you connect the start of the winding of phase A, which we term as T1, say, we connect it to the start of the pole phase group 1. Then we connect the end of the pole phase group 1 to the end of pole phase group 2. Why we are doing this? Because we need to reverse the direction of current in the pole phase group 2. So if in pole phase group 1 the current is flowing from left to right, I need to make a connection in such a way that in pole phase group 2 the current flows from right to left. Hence I am connecting the end of pole phase group 1 with the end of pole phase group 2. Then again I connect the start of the pole phase group 2 with the start of the pole phase group 3. Again, due to same reasons, I need to make the current flow in the directions that are shown by these arrows. Hence, I need to connect the start of the pole phase group 2 to the start of pole phase group 3. Then I connect again, due to similar reasons, I connect the end of the pole phase group 3 to the end of the pole phase group 4. And ultimately I connect the last end, since I have exhausted all the pole phase groups for that particular phase A. Hence I take the last terminal to be the end terminal of that phase that will come out of the terminal box of the electric motor or electric machine, and I term it as T2. So this is a connection diagram. You may pause the video and refer to this diagram for a better understanding. Now we look back at the case of the 24 slot 4 pole configuration. We take the first one for one parallel path. We'll look at method 1. So again in this case, since we had two number of coils in each pole phase group, we have made coil 1 and coil 2 for each pole phase group, and as discussed in the earlier case, each of the consecutive pole phase group must be of opposite polarity. and thus creating the north pole, south pole, north pole and south pole alternatively. Now the consecutive pole phase groups, they must have opposite current direction because of the reason of creating opposite polarity. Then we connect again in similar manner the first pole phase group's start point. We connect it to T1. T1 is the one of the terminals of phase A, where we'll be supplying the power leads. Now we connect the end of pole phase group 1 to the end of pole phase group 2, similar to the earlier case, and again connect the start of pole phase group 2 to the start of pole phase group 3, and again connect the end of pole phase group 3 to the end of pole phase group 4, and the last terminal of the pole phase group 4, since it is the last pole phase group, hence that terminal becomes the end terminal of that phase winding, that is T2. Again, you may pause the video. This is a diagram for the winding, uh, uh, a linear view for this kind of winding. You may pause the video and have a look at it. Now, again, for the 24 slot 4 pole machine, we look at method 2 for the single parallel path only, but we look at method 2. So here again, the consecutive pole phase groups should be of opposite polarity, so they are placed with alternate polarity. Now the consecutive, again, the current direction should be opposite with respect to the earlier pole phase group, just to make the polarity different. Now again we connect the entry terminal for the current flow on the start point of pole phase group 1. Then we connect the end of the pole phase group 1 to the start of pole phase group 3. So here comes the first change, and that's why we call this as the method 2. So in the earlier slide, what we had seen that the end of pole phase group 1 was connected to the end of pole phase group 2. But over here we have what we have done, we have taken the end of pole phase group 1 to the start of pole phase group 3. So here you can see, if we do this connection also, the direction of current is not hampered. We are maintaining the direction of the current required to form the polarity, either north or south as it is shown. We are maintaining that direction of current. Now we connect the end of the end of the pole phase group 3 to the end of the pole phase group 2. So again we have now reversed the direction of the current, but it maintains the requirement of the direction of the current to create that south pole. Then we again connect the start of the pole phase group 2 to the end of pole phase group 4, and at last we connect the start of the pole phase group 4 to the other end of the winding, or the terminal winding, that is T2. So we have seen two methods or two possibilities on how we can connect for a one parallel path case. Now we look at, for the same configuration of 24 slot 4 pole, we look at two parallel path case. So method 1. So, so here you can see again that every parallel path case, there are multiple possibilities that can happen. So in method 1, again you place the consecutive pole phase groups, which should be of opposite polarity. Now that those consecutive pole phase groups must have current directions which are opposite to each other because the polarity is opposite, and we start by connecting the terminal 1 to the start of the pole phase group 1. Then we connect the end of the pole phase group 1 to the end of the pole phase group 2, and we bring the start of the pole phase group 2 to the terminal lead, that is T2. Now there are two other pole phase groups left, so we need to connect them accordingly. So what we do is we follow the same sequence and we bring a parallel path from the terminal T1 and connect it to the start of the pole phase group 3, and then we connect the end of pole phase group 3 to the end of pole phase group 4, and connect the start of pole phase group 4 to the terminal T2. So that's how we connected the two, or rather the four pole phase groups in two parallel paths. So this is one of the methods. Now we look at method 2. This is another method by which we can do it. Again, you place all the pole phase groups in the configuration as shown. Just to note over here, in the below case over here, the pole phase group 3 has been kept towards the right and pole phase group 4 on the left. Now the consecutive pole phase groups again should have the opposite current directions. We connect the terminal 1 to the beginning of the start of the pole phase group 1. We connect the end of pole phase group 1 to the end of pole phase group 2, and we bring the end terminal to the terminal 2, T2. Now similarly we will be connecting the other two pole phase groups. So to maintain the direction of current, what we do, we bring that connection from as a parallel path from T1, terminal 1, and connect to the end of pole phase group 4, and we take the other connection from the end of pole phase group 4, or rather the start of pole phase group 4 to the start of pole phase group 3. This is all done. Just pause the video if you are missing the point. So just check the direction of the currents in the coils that are shown by the arrow. I am making the connections as per those arrows. So that's how the start of the pole phase group 4 has been connected to the start of the pole phase group 3, and the other end, that is the end point of the pole phase group 3, is connected back to T2. So in this case also you can see that two parallel paths have been created among the PPG1, PPG2, 3 and 4. So we have discussed two methods of doing parallel paths. So what are the why we are doing different methods, what are the advantages, what are the disadvantages, we'll be discussing in some other video where we will be having concepts of short jumpers, long jumpers, etc., and what are the benefits, what are the advantages, disadvantages. That will be the topic for some other video, but for the time being I'm showing that even though you may have different number of parallel paths, but within every parallel path you will be having number of methods by which you can achieve that parallel path. So that is one thing to note in all these slides. Now with the same slot pole combination we'll be looking at the last that is the four parallel path configuration. So again we'll be taking all the pole phase groups, we'll be placing on top of one another, and they will be having opposite current directions so as to maintain the north and south polarity as shown. Now we connect the start terminal to the start of the pole phase group 1, and we will be taking the other end of the pole phase group 1 to the end terminal of that phase, that is T2. Similarly we will be connecting the T1 to the end of PPG2, pole phase group 2, so as to maintain the current direction, and we will be connecting the start of PPG2 to the terminal T2. Again in similar manner we will be connecting T1 to the start of PPG3, and the end of PPG3 will be connected to T2. and again T1 will be connected to the end of PPG4, and the start of PPG4 will be connected to T2. So in this way we have again maintained the direction of the current, and by maintaining the direction of the current we have created the north and south poles as required, and we have done this in a 4 parallel path configuration. You may be asking that why do we, or how do we need to choose the number of parallel paths. So that is again a topic of discussion while we are doing machine design course. So there, if you have a high amount of current that is flowing through or that is required by the machine, in those cases we may have to increase the number of parallel paths, as well as when we are not getting the number of turns that is required for each phase, then we can increase the number of parallel paths so that we can have a chance to increase the number of turns as well. So that is a separate discussion topic on electric machines. Maybe we'll be discussing sometime later in a separate series. So we have in this session we have discussed multiple combinations of slot poles. We have discussed about different possibilities of parallel paths. We have discussed different methods within each parallel path that we can follow. So out of all this discussion, what are the important points to remember? Let's just recapitulate. The first thing is, for a given number of poles and phases, or a given combination of poles and phases, the number of pole phase group remains same. Number of pole phase groups is given by number of poles multiplied by number of phases. Consecutive pole phase groups are of opposite polarity. That is how we are getting the direction of current to be opposite in the consecutive pole phase groups. Now, for a given pole phase group, the number of coils may increase, which will increase the number of slots and consequently distribution factor. So again, distribution factor, if you don't know, that is another subject, a subject discussed within electric machine design. But if you are allowed, or the size of the machine allows you to increase the number of slots, it is better to have a more sinusoidal shape of the mmf in the air gap. So we always if it is possible, we try to increase the number of slots, and that increases your distribution factor of the winding. So the matter of the fact is, for a given pole phase group, the number of coils, or if the number of slots increase, the number of coils will increase, but the total number of pole phase groups will remain same. The pole phase groups may be connected in various combinations, giving rise to short jumpers and long jumpers. That I said, it is a topic of a separate session. And this is one thing you should always keep in mind, that the maximum number of parallel path that is possible for a particular machine is limited by the number of poles in that machine. So that is it for this particular session. Let me know in the comments whether this is helpful for you. Any suggestions that you would like to give me that I can incorporate in future videos. Any specific or other topics that you may want me to make a video upon, please let me know in the comments. And thank you for watching, thank you for being through this video, and please subscribe if you like the videos. Thank you.